I'm more than happy to welcome our last presenter on stage, on the blue stage today. He came from Scotland. He works at Chainguard, whose mission is to make the software lifecycle secure by default. He's currently investigating how to enable companies to create secure container images without sacrificing usability or performance. So please welcome on stage with a huge applause, Adrian Mouat from Scotland.
Thank you, Dan. Yeah, thanks for that. So I'm going to talk about supply chain security. I've called this talk Supply Chain Security in Kubernetes, but in reality, most of it's pretty generic software supply chain. There is like a demo with containers and Kubernetes at the end, though. Okay, I'm going to fire straight in. So some background. The reason why supply chain security is a hot topic nowadays is basically just all the news stories. The big one that we all know about is Solarwinds. And what I'd like to point out here, this story is actually from NPR, so National Public Radio in the US, so it became mainstream news. It's no longer just a tech thing. The whole world is now aware of like software supply chains and how badly things go sometimes. And that led directly to the executive order. Well, that and a few other things led to President Biden issuing an executive order on cybersecurity. Some other attacks recently. This is just, of course, it's a US date. That confused me for a second. So that was a recent one on dependency confusion attacks. This is an old one down here. This one's actually, I don't know, some of you probably remember when attackers managed to get a Google certificate issued. And so they could then pretend to be Google and set up sites that looked like they were from Google, which is obviously a really bad place. And that actually, it's a good few years ago now, but it led to the creation of certificate transparency locks. And that's actually a big thing with Sigstore, which we'll see a bit later. But it seems to be getting worse. We're getting more and more supply chain attacks. So even if you're not really interested in it now, you will be interested in the future, because we really need to sort out what's happening here. It's going to keep happening, and it's going to keep getting worse in the short term. But when we talk about supply chain security, it's a bit of a nebulous term. It can apply to a lot of different attacks. The resource that I'd point you towards to understand it better is SALSA. So that's a standard, but you can find that at slsa.dev. We do call it SALSA. And so you can sort of see here what they consider supply chain attacks. It can be a developer or a malicious attacker managing to subvert the source code somehow. It can be somebody attacking the build server and manage to inject stuff there. Or it could be like an upstream package that you depend on that's been attacked or swapped out, for example. And then there's final stuff at the uploading stage to the end user. So we are talking about the whole list. And if you go and look at SALSA, it defines 4 different levels. So level 1 is not too hard to obtain. Any organization should be able to do that with a little bit of work. It includes things like use version control, and I'm sure most of you use version control, or at least I hope you do. But you go up to SALSA level 4, you're unlikely to get there. That's pretty tough. It's a really pretty strict set of things you've got to do to get there. It is quite a long, in-depth document, so I have distilled it down. So this is what I think you need to know about supply chain security. And this is kind of the takeaway for this talk. So 3 things. You've got to keep things updated, or you're going to get hacked. You reduce your dependencies as much as possible. So you run with as little software in production as possible. That's going to help you. And third, you need to know what's running in your cluster. And I'll go into, I bet a lot of you are thinking, well, I do know that. But I'll get onto why I don't think you don't know that, and why I definitely don't think you can prove it later. The other thing I do want to say is note that these are interlinked. If you know what's running in your cluster, well, then it's easier to cut things out and reduce dependencies. And if you reduce all your dependencies, you've got less to update. So they are all interlinked. Yeah, so I'm going to labor this point a little. That's so big, it actually scared me. Yeah, running vulnerable software is going to get you hacked. If you're running out-of-date, vulnerable software in production, it is going to hurt you eventually. And you really need to update it. That's just the way it is. I know it's not as simple as that, because we've all been in a situation where we've updated the library, for example, from like a patch version like 3.2.1 to 3.2.2, and suddenly production's gone down. And it's because of this stupid little tiny change that shouldn't have impacted production, but it did. And that leads people to be very cautious about updating and like force things to run in staging for a week or go through multiple checks with different gatekeepers and so on. But I think that's exactly the wrong thing to do. You should be doing exactly the opposite. In reality, you should be updating more often so it hurts less. Okay? And the way to make it better is to do things like test more. So automated tests should catch as much things as possible before things get deployed to production. Test in production. So if you go and look at talks by people like Charity Major, she'll talk about this a lot more. It's just basically ideas like running canaries. So when you push out a change, push it out to a subset of users. And if it goes okay with the subset of users, who might be internal users, might be power users or something like that, or might just be like at 1% of users, if it goes okay with them, then you roll out to the rest of users. Rollbacks, so I know rollbacks aren't always as simple as they sound because we have databases and schemas and you can't go backwards all the time. But if you can do rollbacks, it definitely helps out. And the key point is to make it easy to update. It should be something we're doing every day. And that really is the way to keep things up to date. Okay, reduce dependencies. So we want to basically offer a small attack surface as possible to attackers. And that basically means in your production servers, run as little as possible. You shouldn't have like debug libraries and stuff. It should just be what's needed to run in production and nothing more. And I'll go into a little bit more detail about this in a minute. The other thing is you should know what's running in your cluster. So if you do like kubectl get nodes, and then you kubectl get pods, you'll see, or get pods all namespaces, you'll get a list of all the pods in your Kubernetes cluster. Now, how many of you think you'd be able to say what each one of those does? So you've got one hand up. So, and to be honest, I reckon a lot of you would be able to say, yeah, this kind of does that kind of does that. You might get a bit stuck in some of like the system pods, for example, but you'd be able to give it a rough guess. What I'm saying is, can you go further? Can you like say what's inside those images? Can you find files like that detail what's in each of those containers? Can you tell what version it's running and if it should be running a newer version? Can you tell who created it, who deployed it? Can you tell how old the image is? Should it have been replaced by now? But perhaps more importantly, can you prove the answers to these? Can you prove that nobody has tampered with this image? Can you prove that somebody hasn't this isn't actually an attacker's container running, and it is actually your software? And honestly, I don't think many people can do this at the minute. And the reason you can't do it is because it's not simple for most people. But we are finally getting to the stage where it's obtainable and doable for most people, I think. So I've kind of distilled it down to these points. Using minimal container images. I'll talk a little bit more about that. Signing your images. So we can now add cryptographic signatures to our containers and stuff, and verify those at deployment time. And that helps to verify that the thing you're deploying is actually the same thing you built, and there's not been somebody tampering with it in the middle. We have SBOMs, or Software Bill of Materials, which details all the stuff inside a container, for example, in all different packages and the versions, and that can be really useful for auditing purposes. At the moment, I might controversially claim it's not hugely useful, and it will become more and more useful with time as we get more tooling around software bill of materials. It's still actually quite a nascent thing. One thing I really think people should be doing is using security scanners. So stuff like Privy, Gripe, Sneak. But there is a problem with these. If you've used them at all, you probably get all these reports. And the problem is, there's all this noise you have to deal with. And I guess a lot of people, it becomes too much work and you stop doing it. And the answer to that is you use minimal images, so less stuff turns up in your security scanners. And minimal images basically comes down to the idea if there's less stuff running in my container and less stuff just lying in the container file system, there's less stuff an attacker can get hold of and use against you. Now you can argue with me that, okay, I have this, just because I have this library or this file in my container doesn't mean an attacker can use it. And you're absolutely right. In most cases, they probably can't. But it's still going to turn up in the security scanner report, and you're still going to have to reason why somebody can't use it. So why not just remove it and don't have to deal with that report? Also, if you have minimal images, it's a bit easier to keep things updated and tracked and so on, because you just got less to work with. If we think about minimal images, most of you have probably worked with Alpine. Yeah, who uses Alpine? Yeah, a few hands. Cool. Yeah, so that's probably the most popular, and I really like it. Some people complain about issues with DNS on Nuzzle. In reality, I would say those aren't really issues. It's more that Alpine does things slightly differently to Debian. And so sometimes things get tripped up because they expect things to work the same way as Debian, and they don't quite work the same way. Distroless. Does anybody use like Google distroless images? Oh, cool. One or two, maybe. Yeah, I really like the Google distroless images. So this takes the minimal container image even further. You don't even have a shell in the container, and you don't have a package manager. So there's no way to do apt install, for example, in the Google distroless images, because they don't have apt in there, even though they're based on the Debian file system. And then you've got a question, well, hang on, how do I debug a container if there's no shell, and so on, and there's no tools in it? And the answer is use a newer version of Kubernetes so that you can use ephemeral containers. And that basically lets you spin up a container in the same pod as the container you want to debug with all the debugging tools that you need. And finally, I do want to briefly mention Chainguard images, because this is what we're working on at my company. And we just announced today, so we're going to come up with commercial images that sort of follow the same distroless approach, but we're also offering SLAs and time to fix vulnerabilities, and they'll come fully signed, and also with software bill of materials. And we will also be having some open source equivalents as well. And that was actually announced today, so you go and look in TechCrunch, you'll find that, and you'll also find another story I'll hopefully talk about later. Signing, yeah. So sign your images to provide provenance. I think most people here probably understand what it means to sign something. You have a public-private key pair. I use my private key to encrypt something, and then if you use your public key to decrypt it, that sort of proves that it was signed by somebody with access to the private key. And that goes a long way to proving that if you're using something that did actually come from me and nobody's had a chance to tamper with it. There is a lot more to provenance and to security than just signing, but it is a big step. I would say it only works if you do actually verify the signatures. Just signing something is useless. You do have to check the signature at some stage. Doing for time, I think good, yeah. Okay, so I'm going to try and run a demo. I am a little bit worried about this because the last time I ran it, it didn't work. Yeah, so just wish me luck. Okay. So I'm going to start off by showing sort of the different images we can get. I do have Wi-Fi. Wonder how good my Wi-Fi is. Oh, that's good. So that's the Nginx stable version from the Docker Hub. So that's a Debian-based Nginx image. This is the Alpine version. And I'm also going to grab the Chainguard version. This is still a development version that I have on my computer. And if we look at them all, you can sort of see the differences. So what do we have? Of course, it all wraps around in a different order to before. But yeah, so this is the, I'll watch this floor. This is the Nginx Debian version at 134 megabytes. This is the Alpine version at 22 megabytes. And these two, I think, are they the same image? I don't know. Those are the Chainguard version. So the Chainguard version is a little bit smaller. It doesn't include APK and things, which is why we managed to cut the size down a bit further. But you can see there's definitely a lot more going on with the Debian image than both the Alpine and Chainguard versions. Oops, push the wrong key. And the result of that, if we run Gripe, so I don't know if you've heard of Gripe, it's basically a security scanner, very similar to Sneak, Trivy, things like that. This is running live, and it seems to be downloading very slowly. So I assume an update has just been pushed to the database in the last half hour, which is a little bit unfortunate. How long is this going to take? I don't want to hit Control-C. How are we doing for time? We're okay. So just to prove this demo is live. Yeah, actually, it's quite interesting, the demo, because I'm using demo magic. So all these commands are scripted, but they are running live, hence things like this happening. Come on, you can do it. Anyway, the point is, when you get the output for Nginx stable, this is the Debian version, and we're going to see a lot of output. And these are all vulnerabilities, the majority of which probably don't affect you. And actually, we'll see like some of them are marked as won't fix, and that's the ones the Debian project have said, hey, you know, we're really not interested in this. We really don't think it can negatively affect anyone, so we're not going to do anything about it. And they're probably right. And then you'll see other ones that are sort of low priority and so on. The problem is, if you're being sort of thoughtful and you're thinking about these things, you kind of want to go through them all and figure out if they do impact you or not. And you know, you kind of got the question, why is somebody marked this as critical if it won't fix? And I don't know. It's possibly because it's like a buffer overflow, but Debian says you're never going to be able to trigger it or something. The key point I really think, though, is there's 143 packages in this. So that's quite a lot of different software packages and quite a lot of complexity. One thing I would say is when we talk about image size, that's not really as important as a number of packages, right? So you know, you could have a large image, but it's got a huge data file. And that doesn't mean it's more vulnerable than a smaller image, right? So it's really the number of packages that you've got to worry about. Of course, normally they're the same. So I'm hoping this one's fast now. We've got the library. Yes. OK, so that's the Alpine version. And we can see there's no vulnerabilities at all in that at the minute, which is great. Let's hope the same is true for the Chainguard one. Good. But again, I've got this point here. There's 42 packages in the Alpine version and only 13 in the Chainguard one. So again, less complexity there. And I think that's, just to explain, I think that's because we don't have things like APK, and also we don't have some of the Nginx plugins installed by default. Of course, you can install those on top. OK, so now I'm going to show the other things like the Chainguard image is one, it has a signature. So we're going to use cosign, which I'll talk about a little bit more later. But cosign can basically be used to verify a signature. Yeah, and there you see a signature. In this case, I've used keyless signing with this, and I've signed it myself. So kind of the guarantee you're getting here is this signature came from somebody that used the GitHub OIDC and had access to the Adrian at adrianmouat.com email. And it also comes with a software bill of materials. There is a slight awkwardness with getting the software bill of materials at the minute. You saw I had to put in a big long SHA there. That's because if I put in just the name, it gets confused because it's a multi-arc image. So I have to use the SHA for the actual image that I'm interested in for the given architecture, if that makes sense, which is a little bit annoying. But this is the SBOM for the Linux AMD64 version of that image. And you can see that sort of what's in there. It's basically a list of packages. You're going to see stuff like S6, which is a supervisor, some libraries, Nginx, of course, and yeah, zlib, things like that. Okay, so this is the bit that could go horribly wrong. I'm going to try and show an example of signing an image, basically. So I've copied this image to a new version. So this is unsigned, basically. I've probably chosen a bad example. I should have used just a random image. This cgr.dev nginx could be anything. Just the point is that we've got an image that we want to sign. I'm going to push that to a repo. This should be quick, because I think it already has the underlying blobs. That looks good. Now, to sign something, what you normally do is you create like a private-public key pair, right? And that's kind of a bit annoying, because you end up with this private key that you've got to worry about. And you've got to save it somewhere, or save it on your laptop, or put it in a vault somewhere, or a key management system, and worry about it, and worry about somebody getting access to it. And really, it's just an enormous pain. So, we're not going to do that. And we're going to use what's called keyless signing. So note in this cosign command, I've done sign, and I've not passed the key at all. If you want to try this at home, you will need to do cosign experimental equals 1, which you maybe saw earlier, for this to work. Hopefully soon you won't need that. And when I do that, it brings up this. And it's asking me to authenticate with OIDC. And I can use any of these providers. I'm going to choose this one. Okay, and it's happy. And basically, it's going to go off to a service called Fulcio and ask for a certificate based on this OIDC credential. It's going to give me a very short-lived 20-minute certificate. So even if somebody else gets access to it, they can't use it for very long. And then it's going to upload both that certificate and the fact that it signed an image with it to a transparency log, which is exactly the same as the certificate transparency stuff that if you've seen that before with the certificate authorities. Okay, and that's actually pushed the signature up to the Docker Hub as a blob in the registry. So next step is, how do we verify that? Well, I just do cosign verify. And it goes off to the Docker Hub. And we hope the Wi-Fi works. And there we go. And that's our signature that we just pushed. Again, we can see that I went through GitHub, OIDC, and it was signed by that login. There's some other stuff. You can add annotations. This is to do with the Recker transparency log and inclusion proof. If you want to understand how all that works, I'm afraid you'll have to ask somebody smarter than me. Right, so we have a signed image. I also have a Kubernetes install here. This is the bit that didn't work last time I ran through it, so please everybody cross your fingers. So I got a Kubernetes cluster running on my laptop, and it has Kyverno, which is basically an emission controller running on it. It has no other pods at all running at the minute. And I'm going to configure Kyverno using this, the cluster policy. And basically, we're asking Kyverno to verify all images. So the star is saying all images. I could also say, put in a registry or a repository in there and say I'm only interested in these ones being signed by this key. In this case, I've said I want the trust root to be this. So this is the Falsio trust root. So that's what would have signed the certificate, or the public part of the key that signed the certificate. That was issued to me a minute ago. Okay, let's apply that. Now, if I run a random image, so this is just a random image from the Docker Hub, we get this output. And it's basically saying Kyverno denied the request because there's no matching signature, which is quite right. Okay, so this is the bit that didn't work earlier. I've not worked out exactly why. We'll see. It was working this morning, and then it wasn't working this afternoon. We'll see if it times out again. I think it's going to time out again. There seems to be some issue. Oh no, it worked. I shouldn't have said that. Okay, so that works. So basically we can see, because this image was signed, it allowed it to run. And you can imagine also having policies like any image that runs in my production server will be signed with by my production cert, for example. Okay, I think that's it for the demo. How am I doing for time? 4 minutes. This is almost gone on time, amazing. So, this is how all that keyless signing works. I mean, I kind of hate the term keyless signing. It's like serverless. In serverless, there's no servers except, of course, there is all the servers. It's just you don't have to deal with them. Same with keyless. There are keys. You just don't have to worry about them. But that's basically what happened. I requested a certificate. It came from Falsio. I used OpenID. Signed the artifact. Interesting bit over here. As an end user, you not only want to check the trust root, you actually also want to go to the record transparency log and make sure there's an entry there corresponding to that, which reduces the amount of trust you have to have in the OpenID server. Okay, I'm just going to try and wrap things up. This is my big takeaways. What I really want you to be doing is updating all your software and keeping them running up to date. So you do not run vulnerable versions of software. Reduce the dependencies, try and run as little as possible in production. And even tomorrow, go through all the pods that you have running and try and figure out if you know what they are and if you can prove what they are. So one thing I forgot to say was, starting with the last Kubernetes release, all the Kubernetes images are now signed using Sigstore. So they would have passed that last demo. I would have been able to run Kubernetes pods because they would have been signed by the Falsio root. And that way you've been able to prove, hey, that came from where I thought it came from. Yep, solving this, minimal container images, have a look at distro lists, Chainguard images, if you will. Sign your images and verify them, things like Kyverno. Have a look into producing SBOMs, software bill of materials, and the new tooling that's starting to come out around that. And yeah, I definitely would use security scanners and actually look at the results, which I know is difficult because of the amount of output they can produce, but I think it's definitely still worth it. Okay, that was all. Do you have questions?
Congrats. This is a small present from craft organizers for you. So thanks a lot for being here. I hope you can drink it.
Thank you very much.
I hope you can carry it back home or you drink it tonight. So it's two possibilities to wait. Okay. But other than we checked that there are lots of questions on Slido. So if you if you can check behind me.
Please don't ask anything complicated to do with cryptography.
I would like to ask you to upvote the questions which are important for you. We have around 11 minutes for Q&A, and then I will cut and finish the day. So let's check the first. What's your opinion on network policies? How much of an issue are vulnerabilities in a pod that's not allowed to access arbitrary addresses in the internet?
Yeah, I mean, that's a good question. I kind of feel that goes back to I'm old enough to remember when everybody talked about firewalls and that was the way to secure everything. And what it ended up with was people that had a firewall, and everything behind the firewall, there was no security at all. And that was not a good situation, as it turns out. And it's sort of the same. You're right, it shouldn't be possible to hack it because it can't do it, and definitely use network policies. But I would also say defense in depth. There's no point in running something vulnerable just because you think somebody can't reach it. I hope that answers the question.
Okay, from security perspective, how would you order the base images, Alpine, Debian, or Rocky?
Well, I mean, you've got Chainguard at the top. I don't know, I kind of don't want to do that because, I'm not objective. But what I would say is, just look at it yourself. We have a paper, actually. If you go to the Chainguard blog, there's a paper called All About That Base Image, and it goes through some of the base images and the various vulnerabilities. So I would just look at it yourself and try running a few security scanners and decide for yourself.
Okay, next question. How can you automate the signing step on, for example, a CI server when you need an interactive login session?
Yes. I'm glad you asked that. I could have shown this actually. So you don't basically, if you're on GitHub Actions, it can use the GitHub, there's basically a GitHub token associated with that can be used for the sign-in. So in GitHub Actions, it just works, which is pretty cool. And I think there's support for some other stuff as well.
What are your favorite security scanners?
Well, you saw I used Gripe there, and that one does seem to be updated a little bit faster. I had a problem recently because the version of Alpine got updated, but Privy wasn't aware of it, so it was getting confused. So I like Gripe at the minute, but I mean, I have no affiliation with any of those companies.
How do you add on packages like NGINX modules to distro-less images?
Yeah. So in Chainguard images, which is based on distro-less, we have a tool called Melange that lets you build APK packages with any files you want to add. And then you install those APKs using a tool called APKO. And so basically, at build time, you'll run APKO and it will install all the APKs that you want. But in the resultant image, there will be no package manager, if that makes sense.
Okay, these two bins. So where does typo squatting fit on your second slide? Yes, the one about possible supply chain attack vectors.
Oh, maybe I can't go back. I think it's, yeah, I mean, that's an interesting one because I think it probably occurs in more than one place because you could have a typo squat on a package like for your node, and it can also occur in third-party source. So, yeah, I mean, I probably have to go back to this slide, but if you look at Salsa, I think it literally calls that out, and so it will show you where it fits in that diagram. But I suspect you could argue it's at both ends.
That's cool. Yeah, network policies are done. Scanners. Is there a good way of signing third-party images deployed via Helm charts?
Well, the best thing to do is to get the third parties to sign their own images. But the other thing you can do, let me think. Yeah, I guess you could mirror the images, and on your mirror, you sign the images. So when you pull the images in, you add your own signatures to sort of verify that you got them from here. And I guess that would work. But the best way would be to get upstream to start signing.
How detailed do you recommend investigating open source dependencies?
I mean,
I know it's a tough question. Yeah.
Well, it's a good question. It's just, how long's a bit of piece of string? I mean, exactly, you go forever, couldn't you? It depends on your risk, I guess, and like how important that dependency is to your organization and how exposed it is. So very context dependent. It's a good thing to think about. I guess it's a good question to ask.
How Gripe checks images.
Oh, yeah, so all the scanners, I think, work in a very similar way. They just look at the sort of package repository. So all they're doing is they're going to APK or they're going to apps or whatever it is and asking for a list of installed packages. Now that's interesting because it means if you compile Nginx from source, for example, and put it in, then it's not going to appear in the package manager. And so those tools are not going to find it. And with our tool in APKO, because it's all based on APK, everything does get added to the package manager, and therefore the scanners do find it.
And the last question on the board is, how do you verify that Kyverno image hasn't been tampered with?
Well, that's a good question. I think they do. I think the Kyverno images are signed, I think. Yeah, it is signing again.
Okay, sorry for bombarding you with questions, but you're really great guys because you made him sweat, I think. I was not expecting so many questions, but we still have time from the Q&A, so if you have anything to ask, you can go for it, but if nothing will come in like in 30 seconds, I will just finish it, and then off the stage you can ask some questions from Adrian. Will you stay for the party tonight?
Yeah, I'm going to have to run to the keynote actually as well.
Okay.
So
you will go to the keynote. If you can, you will stay for the keynote too, Victor? Okay,
there's a party in the main area tonight, isn't it?
Yeah, it will be here as far as I know. So you have 4 coupons on your tickets. You can drink 4 things for free. Okay, you already paid with your conference ticket for the drinks, but all in all, you don't have to use your own cash. Thank you very much, Adrian, for being here with us today. I think it was a really interesting presentation.